All right, here we are, the final chapter in our PHP roadmap. We've gone all the way from the basic syntax right through to fine-tuning performance. And now we're going to pull back the curtain and see how PHP actually talks to the systems that make your code run. Let's dig into that bridge between your scripts and the server. And this quote, it just nails it. All the optimization we've talked about, it all depends on having a stable, well-configured environment. So let's dive into what that environment really is, starting with how PHP talks directly to the operating system. You know, it's so easy to just think of PHP as this thing that spits out web pages, but its power goes so much deeper than that. At its core, PHP is a program that can give direct commands to the server's operating system, which, well, that opens up a whole world of possibilities. So for our first section, we're going to explore these direct system-level interactions. These are the moments when your PHP script kind of breaks out of its little box and starts talking directly to the server itself. This is a total game changer for automation. I mean, imagine triggering system backups, converting files, or running command line tools, all right from your PHP application. It is incredibly powerful, but, and this is a big but, you have to be so careful. Never, ever pass raw user input to these functions. That is one of the fastest ways to open up a massive security hole. So what we're looking at here is pretty amazing. With just one line, exec ls, $output, we're running the ls command, you know, the one you type into a terminal to list files. And the best part? The entire output gets neatly captured line by line into that $output array. Your script can then do whatever it wants with that data. It's a simple function, but it's the gateway to some seriously powerful scripting. Okay, so if executing commands is like giving orders, then process control, well, that's like building your own team. The PCNTL extension lets a PHP script literally fork itself, creating child processes that run on their own. This is absolutely crucial for long-running jobs, like working through a huge queue of tasks, without making your main application grind to a halt. This little block of code shows exactly how that forking works. When PCNTL_fork gets called, the script splits in two. The original process, the parent, gets the process ID number of the new child, but the child process, it gets a PID of 0. And that simple difference is how you write your code to tell the parent and the child to do different things at the same time. Now, let's talk about something that's absolutely critical for security: environment variables. Instead of writing your API keys or database passwords directly into your code, which is a huge no-no, you store them in the server's environment. Then your PHP script can just pull them in securely using getEnv. This keeps all your secrets safe and sound and completely out of your version control history. Okay, so we've seen how PHP talks to the system, but what about configuring PHP itself? How can we fine-tune its behavior and really dial in its performance? Think of it this way. If your PHP application is a car, then the php.ini file, that's the engine control unit. It's the central place where you set all the rules and resource limits for your entire PHP environment. Getting comfortable with this file is, without a doubt, a key skill for any serious PHP developer. And these directives right here, they give you some serious control over your app's resources. Is your script doing some heavy lifting with data? You can bump up the memory limit. Need to handle big file uploads? You'll need to adjust upload max file size and post max size. Got a long process that needs more time? Increase max execution time. This is how you tailor the PHP environment to fit your application's exact needs. And really, that's the whole point. By mastering these things, system commands, process control, configuration, you're elevating PHP. It stops being just a simple scripting language and becomes a powerful, server-aware runtime that can build some truly robust applications. So, you've written your masterpiece of code. You've configured the runtime perfectly. But how does that code actually get from your server all the way to a user's web browser? What's that final link in the chain? Well, that bridge, that's the web server. It's the piece of software that's always listening for requests from the internet. When a request comes in for a PHP file, the web server grabs it, hands it off to the PHP runtime to do its magic, and then sends the final result back to the user. When it comes to the PHP world, there are really two heavyweights in the ring: Apache and Nginx. And while they both do the same basic job, they're built completely differently. Apache is the time-tested workhorse. It's known for being stable and super flexible. Nginx is the newer challenger, built from the ground up for speed and handling tons of traffic at once. Apache is, well, it's the old guard, the backbone of the internet for literally decades. Its classic way of working with PHP is through a module called mod PHP, which basically sticks the PHP interpreter right inside the Apache process itself. This makes setting things up pretty straightforward, and it's famous for being rock solid, especially if you use its recommended pre-fork model. And you can see that simplicity right here in the configuration. This files match block just tells Apache, hey, anytime you see a file ending in .php, hand it over to the PHP handler. It's simple, it's clear, and it just works. Okay, now for the other contender, Nginx. This server was built to handle an insane number of connections at the same time, all while using very little memory. And here's the key difference. Instead of embedding PHP, Nginx talks to a totally separate process manager called PHP FPM. That separation is the secret to its amazing performance. And you can see that different architecture right in this config snippet. The location block finds the PHP files, but instead of handling them itself, it uses fastCGI pass to hand off the request to PHP FPM through something called a Unix socket. It's this design that lets Nginx respond to requests with incredible speed. And that's it. From your very first line of code to optimizing its performance, all the way to understanding how it actually gets served to the world, you've now seen the full picture. You've built a solid, complete understanding of the entire PHP ecosystem. This is the end of our PHP roadmap, but it is absolutely just the beginning of your journey as a developer. So the big question is, where do you go from here? Well, we see three main paths opening up for you. You could go even deeper into backend development, exploring powerful frameworks and building complex APIs. Or if you want the bigger picture, our system design roadmap will teach you how to architect large-scale applications. Or you could master the whole pipeline from code to deployment with our DevOps roadmap. The choice is yours. Seriously, take a moment and let that sink in. What you've just done is huge. PHP is a true cornerstone of the web, powering a massive chunk of the internet. By finishing this roadmap, you have built an incredibly powerful and valuable set of skills. Congratulations on completing the PHP roadmap. We can't wait to see you on your next learning adventure. This has been Developer Roadmaps, where we help you map your path and build your career.